pyramid is, well, you do the base area of the pyramid plus, for lateral area, it was 1/2 perimeter slant height. Okay, that's just for the, oh, well, okay. Actually, I kind of did something wrong. You guys know what I did wrong? The base of this pyramid, is it actually on the surface? No. So, we don't need to find the base area of that pyramid. So we just need the lateral surface areas of the pyramid, 1/2 perimeter slant height, plus the rectangular prism on the bottom of the house. So it has one base that's on the surface, right? And the top of the rectangular prism is not on the surface, so we don't need to find that. So we just need one base of the rectangular prism plus, how did we find the lateral surface area of the rectangular prism? Perimeter of the prism times perimeter of the prism's base times the height of the prism. So this is the lateral surface area for a pyramid. Usually on prisms we have 2B, right? But why did I say it's not 2B? Because the top of the prism is inside the house, it's not really on the surface. Okay, anyways, guess we'll start with this. 1/2, what's the perimeter of the base?
24.
Yeah, the base is a square, so it's 6, 6, 6, 6. So 6 times 4, or 24. What's the slant height of the pyramid? Oh no, they didn't tell us. We're gonna have to find it ourselves. Okay, let's start with, can you guys tell what the height of the pyramid, the normal height of the pyramid is?
7 feet.
No.
Oh, 3.5. Yeah.
No.
Oh.
Did you say, oh you said it. 4, yeah.
Oh, okay.
How did she know it was 4?
How does she guess?
No, she did not guess.
Are you sure?
Yeah.
Maybe you guess.
Maybe it's kidding.
Okay, because from the very tip top point of the roof all the way to the ground is 7 feet, but the rectangular part is only 3 feet tall. So that leaves 4 feet for the pyramid. And how long would this be from like here to here? It's like the hypotenuse, it'd be half of this square. So if the square is 6, this would be a 3. Okay, so to find the slant height, you guys know where I'm going with this? Pythagorean theorem. Okay, maybe you guys have this one memorized. 3, 4, blank. 5. Okay, you could do the Pythagorean theorem, but this is like the most common right triangle, 3, 4, 5. So, because it's the smallest numbers that actually work together. Anyway, all that just to say that the slant height was a 5. Whoops. Okay, plus the base area, whoops. Yeah. Anyway, how do I find the base area? Yeah, it's a 6 by 6 square. So 6 times 6 is 36. So that's the bottom of the thing. And then the perimeter is still 24, just like it was over here. Times the height. This time the heights, we're not talking about the height of the pyramid, we're just talking about the height of the, yeah, that was a 3. So all that will do it. It's quite a bit of work. I think on the homework I made this one like a bonus, but Okay, so on 20 it says find the volume of the same picture. So what would our plan of attack be for finding the volume?
Perimeter times height. Right?
No, that's for lateral surface area of the house. Of a cylinder, of a prism. Well, you'd have to find the volume of the pyramid plus the volume of the prism. Right? Just add those two volumes together. We already talked about the height of the pyramid, right? Did you guys ever find your notes from whenever that was? Okay, now we're jumping to 26. Do I need to help you on 26?
Yeah.
Have you actually read it?
Yes, no.
And get on. You can find a reason to get on to you either way.
There's a word problem, yes, we know. There's an and.
I think it's just talking about a piston, which is like a cylinder or something. The size of an engine is designated by the total volume of displacement in its cylinders. The displacement is a single cylinder determined by its diameter or bore, and the piston travels within the cylinder at stroke. It's kind of talking about, the combustion engine parts, but you don't really need to know how it works.
Wait, I'm on 20.
What?
On 20, would you do 1/2 base times height? Or would you not even do that?
For a pyramid?
No, for the rectangle. Because I guess you do both of them.
Yeah, for the volume of a rectangular prism, it's like area of the base times height, length times width times height. Okay. Anyway, I think they're just talking about a cylinder, basically. It's kind of explains that bore, B-O-R-E, means diameter of the. So if you look at that picture, it's the blue. The blue is the cylinder they're talking about. You guys see what I'm talking about? I think we're just supposed to find the volume, probably. Find the displacement of a cylinder with a bore of 4 and a stroke of 3. So the stroke would be like the what?
Stroke the height.
It'd be the height of the cylinder, and the bore would be the diameter of the cylinder. Like the bigger the cylinder is, the more. I want to try to explain how pistons work, but the more gas that goes in, and then the more energy that can come out of it, basically. So it's just a volume question. So, yeah, basically it's a cylinder. You guys remember the cylinder volume? It's area of the base. What's the base? R squared times I. Yeah, remember volumes are kind of easier. So that's how you, but it tells us, it doesn't tell us the radius, it tells us the bore, which means the diameter is 4 inches. And the stroke is the height of the cylinder, 3.482. Yeah, and then for B it just says, well, what if the engine has 8 cylinders? So you just take your answer to A and multiply it by 8. Okay, see, it's not that bad.
Wait, what do you do for B?
It says, what if you have 8 cylinders? How much displacement is there? So you just do A times 8. Yeah. If you have a little car like mine, it's 4 cylinders. Probably a 6-cylinder engine is average. 8 would be like a big truck or something. Need more power for bigger vehicles. But if you only have 4 cylinders, you get better gas mileage. So, 27. Derive an expression for the altitude of a regular tetrahedron. I just bugged out. I don't think I want to do 27.
Yay!
It'd be
I
like-
didn't want to do 27 either.
What a coincidence.
How could you?
It would be kind of like 23, but it's probably not worth it.
You have to do 28.
Yeah, nah. I mean, I could do it. I can sit up here and talk for 5 minutes and you're gonna not hold me accountable to that. 29, find the surface area of a sphere with a radius of 14. Alright. Does anybody have access to their sphere formulas? Okay, you guys need to put your notes in some place where you can find them. What good is it to take notes if you don't know where they are? The worksheet, well, the worksheet's in here, but you knew you were going to turn it in too. I could hunt it down, but I'm not going to. Anyways, so a sphere formula for the surface area, it was 4 pi r squared. I think the book just called it area because there's only one surface on a sphere. For the volume, you might think they might remember that one, maybe. No. It's kind of weird. 4/3 pi r cubed. Babe, I don't want to call you out, but you didn't put the little cube on that one. On the sphere homework. You weren't using the 3. You used a square instead of the. So you use a square on the area and the cube is on the volume. Where was I? 29? Surface area. So we're just going to plug, the radius is 14. Just going to plug in 14 right here. 14 squared times 4 times pi. Probably not going to plug pi in. $784.
Yes. How do you do that again? You got a big
Magic.
math teacher, Terrence.
I used a trick. I didn't do normal multiplying. What are we using here? Feet, meters, meters. What is the surface area of the moon? So on 30, it just gives you the diameter. So if the diameter is 18, the radius is 9. On 31, what's the surface area of the moon? To the nearest 1,000 square miles. So we're rounding to the thousands place. You guys aren't very good at following directions when it tells you where to round it, by the way. So you need to read the question and apply. But anyway, if its diameter is approximately 2160. So if the diameter of the moon is 2,160 miles, then guess what? We need the radius, and it is 1,080, yes. Well, not equal to the arrow. 1,080 miles is radius. So it's just surface area again. So same formula as before. It's just the number is much bigger. Okay, since it told us to round to the nearest 1,000 miles, that means we should actually plug pi in the calculator. So we can get an accurate estimate. Does that make sense? Because when we're putting pi in, we're not really giving them like to the mile answer. But since we are supposed to round it, we should put pi in there. Cadence, what'd you get?
1, 4, 6, 4, 9, 9, 8, 4.
What? 998.
1,000. You're supposed to round them 1,000.
Is that it? No, that's not right. There's too many zeros. What came after the 8?
4.
That was it?
Yeah.
Okay. So we're supposed to round to the thousands place, which is what?
1, 4. Wait. 1, 4, 6. It would be 1,465.
Okay, this is the thousands place.
Oh.
What's this 9 gonna do to that 9?
Sure.
Push it up. So 9 rounds up to 10, but 10's too big for one spot, so it's gonna push the next one up.
So 650.
Yeah. And how do we say that?
Square numbers.
No, how do we say this number?
Oh.
1,650,000
Yeah.
miles squared. Square miles.
Sounds like a lot. It is a lot, but that's just the moon, so the Earth would be a lot more than that. Oklahoma's probably like, I don't know, 15,000 square miles or something like that. They stack up quickly. All right. Now what? To describe how the surface area would change. The radius would quadrupled. Yeah, that's probably going to cause some problems. So on 32 it says describe how the surface area and the volume would change if the radius were quadrupled. What does quadrupled mean?
Times 4.
So if we quadrupled the radius times 4, how much bigger would this sphere be than this sphere? This is for surface. This is just surface area right now.
Where we just did it.
Yeah, it's 32.
Should be 4 times bigger, right?
Okay, I just replaced the radius with 4 times the radius. Okay,
8 times bigger?
what happens if we square this? What would that turn into?
8 R's.
No? 16,
Oh, yeah.
what? R squared. So, how many times bigger is this sphere than this sphere? 16 times bigger. So if you quadruple, if you make the radius 4 times bigger, the surface area is 16 times bigger. So if the radius of the Earth was like twice the radius of the moon, I'm not sure if that's probably not true, but the surface area of the Earth would actually be 4 times the surface area of the moon. Okay, and then it asks the same thing, but with the volume. How much bigger would the volume be? So this is the volume formula of a sphere, and if we make the radius 4 times bigger, it would look like that. And what's 4r cubed?
6.
Somebody said it, I think.
64.
64. 4 to the 4th would be 256. 4 to the 3rd is 64. So how many times bigger is this sphere going to be than this one? 64 times bigger. Makes a big difference. It cubes the multiplier. So anyway, the radius is 4 times bigger. The volume is 64 times bigger. Yep. The book didn't write as much as I wrote. They just put multiplied by 16, multiplied by 64. Okay. Number 33. Metal balls with a radius of 2 inches are to be melted and poured. So if we're talking about a ball, what shape are we talking about? Sphere. So we got to use the sphere formula again. Are poured into a mold. So they're melted and then poured into. You guys know what a mold is? You guys know what they're talking about? It's like when you want to make something. A lot of times it's like there's plastic molds. It's kind of like a cookie cutter thing. Like you pour something in.
Like an ice cube mold.
But yeah, they do this with metal. This is how they form metal. They melt the metal, they pour it in, and then it cools and hardens into whatever shape they want it to be. Anyways, into a mold that is shaped as a 14-inch tall cone with a base of 27 inches. How many balls are needed to fill the mold? I read that pretty quickly. So we have a bunch of little ball bearings, you know, whatever. And we're supposed to fill a cone. Maybe I should draw it the other way around. So it looks like you can draw
Ice
it.
cream cone.
And the question is, how many of these little balls can we fit inside this if they're melted down so they're like liquid? Any ideas for a game plan here? Huh?
Not do it.
No, we're doing this one. Okay. We need to figure out how big one of these is. And then,
To find the volume of one of them.
yes, and figure out how big this is. And then what? So let's do a really easy example. Let's say this was 1 cubic centimeter. And let's say, or maybe I'll say it's 2, just to make it a little bit of a, let's say the cone is 50 cubic centimeters. So how many balls could fit and how many would it take? 25. So what did you do basically? You divided. So you do the volume of the cone divided by the volume of one of those little guys. Okay. Of course, nobody has access to their formulas, right? What's the cone volume? I think, did we talk about this one today?
Yeah.
Maybe yesterday we talked about it. 1/3. Oh, Jared actually remembers it. It's starting to get in his brain. 1/3 pi r squared h, and whatever that is, we're going to divide by, what's the sphere formula? I just wrote that like 3 minutes ago.
1/3 pi.
Alright, so that's the game plan. That wasn't that bad, was it? The balls have a radius of 2 inches, so they're actually a lot bigger than I drew. But so we're going to put a 2 over here for the sphere. Get out of here. So the spheres, or the, let's see, shaped a 14-inch tall cone. So that's the height. With a base of 20. Okay, actually they already found the base area for us. You guys know how I knew that? Because it just said the base is 27 square inches. So we don't have to do the higher squared part. Because they already told us what the base area was, like the circle. It just says with a base of 27 square inches. So anyway, the 27 is going to go where the circle area went. The height of the cone is 14, so that would do it. Should we plug pi in or not?
Yes.
Yes, we should plug pi in, because we want an actual full number so we can divide this right.
What do you want us to round? This first one?
Does it say?
Under.
Well, you can't use like a half of a ball, so you're gonna have to round up to the next ball. You know what I'm saying?
Oh, yeah.
So just round up to the next one. My drawing is not accurate because I didn't draw the balls big enough. They're actually 2-inch radius. Yeah, anyways, so it's not going to take a lot of them to fill that up. All right, what'd we get? Hopefully 3 point something, right?
3.76.
So, yeah, so you gotta use 4 basically to cover it all. So the answer is 3.7 rounds up to 4. Okay, we're almost done. 34 says find the volume of water that would be required to fill the space between. So what's the game plan for 34? How do we find the space between the cylinder? They drew the picture on the right. How do we find the space between the cylinder and the sphere?
Find the volume of the cylinder.
Right. Volume of the cylinder minus volume of the sphere. That would give you the air in between it. 35 and 36, I guess. Name the city located. You guys still have your. Oh, I don't think I have my map pulled up. Why don't you guys work on the evens while I pull up the map and I'll find that city. What's 36 say? Find the latitude and longitude of Athens, Greece.
Mr. Jordan. How do you find the volume of a cylinder?
Pi r squared h. It looks so serious. Actually, guys, you can use this if you want to, or your computer, but I'll leave 35 and 36 to you.
I don't know where 35 is.
Okay, 12 degrees south. Remember on this map, most maps they count by 15 degrees. So 12 degrees south would be like the middle of Brazil. And 77 degrees west. So it's 0, 15, well, you can look down here too. 60, this would be 75 right here. So I'm pretty much just pointing at it. If you're 10 degrees off, you might have been looking at the wrong line. Like this one is 60, but this one's 75. Maybe that was a problem.
Yeah, no, it's 41.
Wait, that middle one's 75?
You do have.
This one's 60.
No, that's 60, yeah. Okay, there's one in between 90 and
This
60.
is, yes.
Okay, that makes sense.